Hi everyone. So let me prove some theorems in this class based on your limit. So you know that the definition of limit is a real number L is said to be limit point of f of x as x tends to a if for any epsilon greater than 0 there exists a corresponding delta greater than 0 such that modulus of f of x minus L is less than epsilon wherever your 0 is less than modulus of x minus a is less than modulus of x minus a is less than delta. So using that definition we prove this result, that is if limit x tends to a is equal to limit x tends to a f of x is equal to L and limit x tends to a g of x is equal to m, then prove that limit x tends to a f of x into g of x is equal to L into m. So limit x tends to a f of x into g of x is equal to L into m. So we have to prove this result. So proof for this is I take here modulus of f of x into g of x minus L into m is equal to, here I add and subtract minus f of x into m and plus f of x into m. So then your equation, this equation becomes modulus of f of x into g of x minus f of x into m plus f of x into m minus f of x into n and plus f of x into m minus L into m. So here in this term we take common as f of x. So then remaining term will be g of x minus m. So here I take m as common, then it will become f of x minus L. So using modulus property we can write this as this is less than or equal to modulus of f of x into modulus of g of x minus m plus modulus of m into modulus of f of x minus L. So this is equation number 1. So since limit x tends to a f of x is equal to L and where L is not equal to 0, so if your L is not equal to 0, then your f of x also not equal to 0. In 0 is less than modulus of f of x is less than modulus of x minus a is less than delta for some delta is greater than 0. So therefore f of x is bounded in certain deleted neighborhood of a. Hence there exists k greater than 0 such that your modulus of f of x is less than k. Modulus of f of x is less than k whenever 0 is less than x minus a is less than delta 1 for some delta 1 greater than 0. So here I take, let epsilon greater than 0 be given since you know that limit x tends to a f of x is equal to L and limit x tends to a g of x is equal to m. So using the definition of limit so I can write this as let epsilon greater than 0 be given since you know that limit x tends to a f of x is equal to L and limit x tends to a g of x is equal to m, there exists delta 2 and delta 3 greater than 0 such that here your f of x minus L is less than epsilon by, so this is epsilon is very small quantity, so very negligible quantity. So I can write your epsilon in the form of epsilon divides 2 into 1 plus modulus of m. So I take it as equation number 3. So where 0 is less than x minus a is less than delta 2 and your g of x minus m can be expressed as epsilon divided by 2k for 0 is less than x minus a is less than delta 3. So here delta 1, delta 2, delta 3 is there. So here I take delta is equal to minimum of delta 1, delta 2 and delta 3. So then from equations 2, 3 and 4 your 0 is less than modulus of x minus a is less than delta. So this becomes okay. So therefore from equation 1, so if I substitute the value of 2, 3 and 4, then it will become modulus of f of x into g of x minus L into m is equal to, you know that modulus of f of x and you know that modulus of f of x is less than what? K. So substitute the value of k and you know that g of x minus m is what? epsilon divided by 2k. You know that epsilon divided by 2k. Substitute those two values, k into epsilon by 2k. So here m is there. So m is there. F of x minus L is what? Epsilon divided by 2 into 1 plus modulus of m. Substitute that value. So then your equation becomes modulus of f of x minus g of x, modulus of f of x into g of x minus L into m is less than k into epsilon by 2k plus modulus of m into epsilon divided by 2 into 1 plus modulus of m. Okay, so this k gives, this k vanishes, remaining term is what? Epsilon by 2. Okay, so this is a very negligible term, so epsilon is a very negligible term, so I can write that as epsilon by 2. So you know that epsilon, so half epsilon, so this will become epsilon. So then your equation becomes modulus of f of x into g of x minus L into m is less than what? Epsilon. So again we use the definition of your limit. Okay, so if L is a real number, L is said to be limit of f of x as x tends to a, if for any epsilon greater than 0 there exists corresponding delta greater than 0 such that modulus of f of x minus L is less than epsilon. So here your modulus of f of x minus modulus of f of x into g of x minus L into m is less than epsilon. So using the definition we can write this as limit x tends to a, f of x into g of x is equal to L into m. So this is equal to limit x tends to a, f of x. L is limit x tends to a, f of x, and m is limit x tends to a, g of x. So with this the proof of above theorem is complete. So again we see another proof, that is another theorem, that is if limit x tends to a, f of x is equal to L and limit x tends to a, g of x is equal to m, where m is not equal to 0, then prove that limit x tends to a, f of x divides g of x is equal to limit x tends to a, f of x divides limit x tends to a, g of x, and you know that limit x tends to a, f of x is L and limit x tends to a, g of x is m. So we have to prove that limit x tends to a, f of x divided by g of x is equal to L divides m. So for that proof is, we have here I take modulus of f of x divided by g of x minus L divided by m is equal to, so using cross multiplication it will become m into f of x minus L into g of x divided by m into g of x, m into g of x. So later I add and subtract plus Lm. Okay, add and subtract Lm. So then it will become modulus of m into f of x minus Lm plus Lm minus L into g of x divided by modulus of m into g of x. So here if I take m as common, then it will become f of x minus L. So here if I take common L, then it will become, so this is m minus g of x whole divides modulus of m into g of x. So using so if I write it, this is minus, then also no problem, minus okay, so then it will become this will become okay plus, there is no problem, leave it as it is plus. So if I take modulus for this separately, then it will modulus of m into modulus of f of x minus L plus modulus of L into modulus of modulus of m minus g of x. Then if I take minus common, then it will become modulus of minus into g of x minus m. So you know that my modulus of minus x is what? X. So therefore we can write this as modulus of m into modulus of f of x minus L plus modulus of L into modulus of g of x minus m whole divides modulus of m into modulus of g of x. So take it as equation number 1. So since x tends to a, g of x is equal to m and m is not equal to 0 and g of x also not equal, so then g of x also not equal to 0 in 0 is less than x minus a is less than delta for some delta is greater than 0, for some delta is greater than 0. So take it as delta 1. So this is also delta 1. Okay, and you know that this results holds good because limit using the limit point, this is lies between. So this can be written as modulus of if g of x minus m is less than epsilon, g of x minus g of x modulus of g of x minus m is less than epsilon. So using that we can express that as modulus of m minus epsilon is less than modulus of g of x is less than modulus of m plus epsilon. So this can be expressed in the form of modulus of m minus epsilon is less than modulus of g of x is less than modulus of m plus epsilon. Okay, so therefore this implies that modulus of m by 2 is less than modulus of g of x is less than 3 times modulus of m divided by 2. Modulus of m divided by 2. So for 0 is less than modulus of x minus a is less than delta 1, and the value of epsilon here is modulus of m divided by 2. If you substitute the value modulus of m divided by 2 in this equation, so modulus of m minus modulus of m by 2, so then it will become half of modulus of m divided by 2. So this will be modulus of m plus modulus of m divided by 2. So using cross multiplication, it will become 2 times modulus of m plus modulus of m divided by 2. So that is 3 times modulus of m divided by 2. So let epsilon greater than 0 be given. So using the limit, here we can definition of limit. So we can express this in the form of let epsilon greater than 0 be given, since limit extends to f of x is equal to L, and this can be expressed as modulus of f of x minus L is less than modulus of m into epsilon divided by 4. So this is epsilon is a very small quantity. So we can for small quantity, if you multiply with a bigger quantity, then also it will become a very small quantity. Okay, so it will modulus of f of x minus L is less than modulus of m into epsilon divided by 4. For 0 is less than modulus of x minus a is less than delta 2. So again we use again another definition, that is limit extends to a g of x is equal to m. So then it will become modulus of g of x minus m is less than modulus of m square into epsilon divided by 4 times 1 plus modulus of L. For 0 is less than modulus of x minus a is less than delta 3. And here I take delta is equal to minimum of delta 1, delta 2 and delta 3. So from equations 2, 3, 4 hold for 0 is less than x minus a is less than delta. So therefore substitute all these values which equation 2, 3, 4 in equation 1, then you get modulus of f of x divided by j of x minus L divided by m is first is modulus of m into modulus of f of x minus L in equation number 1. So modulus of m as it is, and you know that modulus of f of x minus L is modulus of m into epsilon divided by 4. So modulus of m into epsilon divided by 4 plus modulus of L into modulus of g of x minus m. So you substitute the value of modulus of g of x minus m, that is modulus of m square into epsilon divided by 4 times 1 plus modulus of L. Okay, modulus of L whole divided by modulus of m into this value. So that is this. So modulus of g of x is greater than, means this is now modulus of m by 2 is less than, because this is in the denominator term, so we have to take here greater term. So therefore modulus of m by 2 I take here. So modulus of m into modulus of m divided by 2. Here we take g of x value is modulus of m divided by 2. So so this is m square divided by modulus of m square into epsilon divided by 4. This is modulus of m square divided by 2. So it will become modulus of m square into epsilon by 4 into 2 divided by modulus of m square. M square vanishes, and 2 ones are 2's are, then it will become epsilon by 2. So this is also becomes m square vanishes, remains what? Epsilon by 2 into modulus of L divided by 1 plus modulus of L. So this is, if you multiply this with epsilon, so this is a very negligible term. So therefore we can take that as epsilon by 2. Epsilon by 2 for 0 is less than modulus of x minus a is less than delta. So using the definition of your limit, so we can express this in the form of limit x tends to a f of x divided by g of x is equal to L by m, and you know that L is equal to limit x tends to a f of x, and you know that m is equal to limit x tends to a g of x. Here your g of x should not be equal to 0 and m should not be equal to 0. Okay. So with this I conclude today's class. If you have any doubts regarding this, you can send questions to my WhatsApp number and clarify your doubts.